Hey everyone, welcome back to the shop. We have a job here from one of our local hot rod shops. I've done some work for them in the past, some stuff you've seen on the channel here. But what they have are some brake parts that need a modification done to them. And I'm told that these parts are going on a 79 Ford Bronco. I'm sure this is a complete custom build, probably some type of restoration that they're doing, but we did not get into specifics about that. We just talked about what it is that they need. But anyway, you've got these two brackets right here. These are both identical. We've got one that's already bolted on, and both of these brackets need a slight modification done to help with the alignment of these parts once they're bolted on to the rear end of the Bronco there. Really nicely machined parts. I have no idea, who's manufacturing this, but really nice job. They are symmetrical, so it doesn't matter which side we machine because they're equal on both sides there. All right, but this one's already bolted to this housing here, how it's going to mount on. And if we look on this side, I've got some black Sharpie marks that shows the radius of this component right here, which actually I believe it was 7. Let me just do another quick measurements here. 7 inches 450 thousandths. That's what this diameter right here is. They've got some machined reliefs in there, but this is a nice symmetrical circle on there. But anyway, you can see the black Sharpie marks. These brackets, where the Sharpie marks are here, this needs to be milled down 1/4 of an inch. And they say that they need that modification done in order to get the alignment correct for the brake disc, the caliper and the brake disc there. So that's what we need to do, is machine these guys down on one side, take it down from this face down 250 thousandths or 1/4 of an inch. All right, so I went ahead and made a little sketch right here, just a hand sketch, getting some quick measurements of our part so that I could model this in Fusion, create a model of it, create these arcs in here that we want, or these radiuses in here that we want, and just post out a simple program that we'll use in our tool room mill to mill this pocket in there, this radius pocket. All right. I used my height gauge and my granite surface plate to quickly and easily get these measurements. So I'll show you a quick little shot of that on how I set up to help measure this part right here. And then I'll show you my Fusion program. This is one that I've been trying to do this one with no help whatsoever. So I created the model, I created the cam on it, and I'm going to try to attempt to do this without calling my lifelines and asking for some help on getting this done. So we'll see if we can knock this job out, and let's go ahead and go get started on it. Okay, we're in here on the granite plate, and I was going to show you how I use my Starrett tools to get some just quick reference measurements that I needed to have in order to quickly model this in Fusion, okay? To get the thickness, simple enough, use some calipers. We measured that at 1 inch and 5 thousandths on the thickness there. And what I wanted to know was what this thickness was here. I want to know what the distance is from this face down to where I think our cut needs to be. That'll be the very top tip of the arc, the radius that we machine in this bracket there. So I wanted a measurement from there to there. And then I also wanted to get a measurement from this face down to where this radius is as well, okay? And that's where having this digital height gauge and the granite plate and some setup blocks made this job very quick and easy. We're not having to get absolutely dead accurate measurements on this. This is really just for modeling purposes on Fusion, okay? So if we're in a couple thousandths, it's not a big deal, all right? So again, we measured the thickness with calipers. That was easy enough. And what I want to do is measure what this thickness is now, all right? This face and this face are not in line with each other. So if you try to use calipers to measure that, you're going to be off a little bit. So since this is actually machined flat on both sides of that, you can set this down and just use the height gauge to get a quick measurement on that, all right? So got our height gauge, and we'll go ahead and bring it down to the granite plate surface to zero it out. All right, there it is, 0. And then we just use this. We've got our factory carbide scriber on there, but this is made so that you can take measurements with it there as well. So we'll just bring that over to this face and just very gently, I just use both fingers to kind of help control the amount of slide and just come down until it touches. Right there I got 2.823. When I measured it earlier, I got 2.825. Now it says 2.824, so you can see we're within 1 or 2 thousandths there of repeating what we measured earlier on that. All right, so that's that thickness there. Now, what I also wanted to see was I want the measurement from this top face down to where I believe the top of our arc is going to be whenever we machine this pocket. All right, and again, we have Sharpie lines on there. So not a huge deal on being dead nuts accurate. I just want something very close. So what I did was we referenced this top surface right there, which we're already on. Okay, we're just going to zero out our height gauge again. And then I just lowered it down. And this is where I just used this as a visual reference on the measurement. I brought it down here and got it really, really close, lined it up, got down here and looked at it. And the measurement that I'm coming up with is right at 1 inch, 125 thousandths, there and about. So that's my measurement that I wrote on my sketch right there, 1 1/8 inches. Now I also want to know what it is from the bottom here to the very end of that radius on the bottom. So the way that I did that, that's where I used my 706 setup blocks right here. You got a nice machine face where those studs are screwed in, but we want to kind of go around that and reference on that flat surface. So that's what we used our setup blocks for right here. Just set that down like so. All right. And then bring our height gauge up. And once again, just lower it down to that face. It's a flat machine face. Coincidentally, that measures 2 inches right there, but we're going to zero it out. And then we're going to bring it over here and just use that scriber tip, which is flat on the bottom and it's radiused. It's radiused on the end. We're just going to barely reach over the top of that inside radius, and we're going to get a measurement right there. Right here it measures 0.777, and when I measured it earlier, I measured it at 0.778. So within a thousandths or two of what we wanted it to be. All right, on our repeat measurements anyway. So I believe that was it. That's the measurements that I wanted to get. We got our total height, and we got our distances from the face down to where the radiuses are. I used my calipers to measure the width of it, which is 6.787, and we already got our thickness, which I didn't write down on this print. But anyway, this is just showing how convenient it is whenever you have one of these digital height gauge and you got a granite plate and you have some setup blocks on how you can use these tools to help you quickly measure sort of odd shaped parts like this that doesn't have a lot of parallel straight lines with each other around the part. Okay, so I think what we'll do is I'll give you a quick rundown of our Fusion model and program. Pretty simple, and then we'll go to the mill and start getting it set up next. Okay, we're in our Fusion program here, and I'm going to show you how I modeled this up. I tried to make it as very simple as possible. So you can see our basic shape here and how I just draw a rectangle, because we don't need to know what all these features are and things like that. We just need to know the overall shape of our parts that we're going to be holding. All right, so our very first sketch that we drop down is just our overall dimensions, our width and our length and width there, which what we have, that should match. And then from there, we just did an extrusion where we extruded that up 1 inch 5 thousandths. All right, and then our next sketch, what I did was I put a series of points on there. So what these points do, and I have them constrained to our origin point in the very center of that, is that these points represent these measurements that we measured at. So those points are actually the very tip of our radius where we want where we want to be like a tangent point of our radius and those points right there. So this is probably not the right way to do this, but again, I'm trying to do this by myself without any help, and I'm just kind of stumbling my way through getting this laid out. But anyway, there's our 2 points, which is gonna reference our arcs, which you'll see next here. So we'll get out of this, and let's see, we want this one right here. So what I did was I created 2 circles of the diameter which we wanted of our part. That's going to be the radius that we're trying to take from our part. So that diameter is 7 inches 450 thousandths. Half of that, which is the radius, is 3.725. So what I did was, once I made the 2 circles and constrained them to be the center of our origin there, I measured it. I used our measure command up here, our sketch dimension, should I say, and just did a dimension from the center of the circle to those points that I dropped on there. Those, and that should create this radius up here exactly where I measured it on our part, okay? Next up, I did an extrusion for our first one. That's just to cut this one away, okay? Remove that. We did an extrusion there. We'll go ahead and move this over so you can see it a little bit easier. So we did an extrusion all the way down through the part. And then our last one is another extrusion here. And this is the area in which we have to machine on our part. So we went down negative 250 thousandths on that extrusion there. And once it did, it cut it out. So this is just representing where we're going to be cutting on our part whenever we get over to the mill. All right, so we'll jump over here to the manufacturer side of it and created a setup, and we're going to have 3 total tool paths. I chose a 2D adaptive for the first one that's going to rough it out, and then a 2D contour, which is going to clean up this wall, and then the last one is just simply a chamfer so we can break that edge off. All right, so we'll go ahead and just simulate this guy right here. We're going to be using a 1/2 inch diameter end mill. We're going to use a 3-flute end mill designed for cutting aluminum. Should work really well for this. I've got a 400,000 step over or optimal load. We are running 8,000 RPM on this with a 3,000ths per tooth chip load. And I've got it 2 step downs, 1/8 of an inch. So the second one will bring it down to the finished face there of 250 thousandths. And I left 20 thousandths on the wall right there to clean up. So once we're through with the adaptive, we're doing a 2D contour. Oh, I got an exit simulation on that, sorry. So the next one is going to be the 2D contour, which is going to clean up this 20 thousandths right there. And I've got this set to wear. So whenever we get this machined, if it looks like I need to move it back a little bit further, give it a little more clearance, because they said they wanted a little bit of clearance between the wall and the bracket that's going to be mounted on there, just so it's got a little bit of room to wiggle around on those holes there, okay? So anyway, if we play that, it's just going to simply make one pass through there to clean up that wall, clean it up nice, and if we need to, I think we can use our wear and shift the cutter over, you know, 5, 10, whatever thousandths we need to kind of come through there and clean that up again. All right, we'll exit that one, and then the last one is just simply going to be another 2D contour. If I do that right, we're going to use a 1/4 inch chamfer mill, and I'm just going to simply come and break that edge off on the top 10 thousandths. All right, so we'll go out there to the TRM and start getting this set up and hopefully have a successful machining project here at the end. For our machining, we're going to use our Milltronics tool room mill. I went ahead and got this set up, save a little bit of time on the video here. We've got a stop set up. We've already got our vise trimmed. I'm using these parallels right here, which are 7/8 in height. I needed those in there in order to, once we set our part in here like this, again, this is all machined, so we have nice, you know, flat ends, nice square machined ends there that we can set this on and slide this up. And once we set it in there and we tighten up our vise, we're going to be taking this face down a 1/4 inch, so we will clear the jaws there. We've got about 3/8 of an inch height sticking up out of the jaw, so our cutter should not hit the vise right there. All right, but I'm going to reposition that, just make sure it's nice and square. Just like so. Now I went ahead and probed this because I wanted to make sure that I get it right. But we'll probe off our X again, so I'll show you how I did that. But getting it in the Y direction here was easy enough. We just did slot and found the center this way. Okay, Z is off this top face right there, so that's our 0 point. And then what I ended up doing is I took a parallel here, this guy, and then if we measure that, I think it was measuring 807. Yeah, so 807 on the thickness of that parallel. And we take this parallel and set it there, all right, so that it's pushed up against these two faces right here. And we probe off of this surface right here. Our X0, I'm sorry, our X0 is actually off of this face, but I want to make sure that it's, you know, on the plane correctly. So if we probe against this parallel and then just do a negative 807, that will put our 0 right on this inside plane. So that's how I ended up doing that right there. I'll go ahead and put the probe in there and show you what I'm talking about. We got our probe in there, our parallel, and we're going to be using single surface X. G54 is our work offset, negative a quarter inch to the part, and our X position is negative 807. All right, so we'll go ahead and run this guy. All right, we're getting ready to hit cycle start on this. What I was going to say is just for simplicity, and I can run this with the door open, I'm just going to hold the parallel against the workpiece, just to keep it, you know, because it can slide around. I want to make sure that it's just up against those two faces. I've got it slowed way down to 20%. Let's see if we can get it done. Just hold it in place. And there we have it. We have our X position. Yep, that looks right. So we're going to go ahead and let's bring our probe up and out of there nice and gentle. Go ahead and get our parallel out of there. And again, I've already found Y. We're in the center, and we touched off the top our Z0, so we already got that done. I just wanted to show you how I was accurately getting our X0 dimension on our part. All right, we'll take our probe out. I've already got our tools installed too. Tool number 1 is going to be our 1/2 inch 3 fluid end mill. Tool number 2 is going to be our 1/4 inch chamfer mill. So those are the only tools we need to get this job done. Just installing the tool number 1. Tool reset. All right, we got our program loaded up here. I'm going to do a preview. There's our adaptive, there's our contour, and there's our chamfer. So on this, it looks pretty good. Hopefully it's going to be the same down here. So I am going to, I'm going to bring my coordinate up. I'm going to go through an air cut. I know Kevin loves that. I'm going to go through an air cut because I want to be able to visually see where the edge of this end mill is with this black Sharpie mark and see if it visually looks like it's in the correct position. All right, we're going to run through my verification on the machine here. I'm just going to bring this down nice and slow. We're already going to be running 8,000 RPM today. That's topped out on our tool room mill here. Let me see what this is going to look like right here. Well, my light is in the way. I got to move it. Let's try that again. All right, now we're got it sped up to 100% here. I set my coordinate a 1/2 inch above the part, by the way. I think it makes 5 passes total. All right, this is the one here. I'm going to slow this down. I'll tell you what I'm going to do. I'm going to stop the spindle. We can continue to run through here without our RPM going. Get that one of those flutes just kind of even. That's looking, from here it's looking like it's lining up with my Sharpie mark. It's looking good. Here's our contour. No, I'm sorry, this is the second depth. So let's just run through it real quick. I've got it sped up to 200%. This will be the contour. This will clean it up. So if I let it get to the center here and stop it. So from my point of view, it looks like the cutter is sort of in the middle of that black Sharpie mark. So I think we're good. I mean, this is looking good. This is giving me confidence that we're in the right position. So I think we're good to go there. I'm going to stop what I'm doing and we're going to restart this program, and we're going to hopefully get this cut correctly. I'm just going to walk it down slow, let everything kind of come in nice and easy before I move too quickly with it. Well, there we have it. I think it worked pretty well. It looks like it lined up well on my Sharpie marks too. And the cut itself took less than 3 minutes to take care of. So I think we got some success there. Hopefully it's going to bolt up like it's supposed to. So the next thing, there's a little bit of chamfer in here that could be better, but since I'm not quite there yet well, the modeling would have had to match the shape here. I was just saying I could have put a chamfer on that edge, but you know what? A little file will knock that off in a few seconds to be done. But I'm happy with it. I think from here we need to just take it out and bolt it up to the main housing and see how it's going to fit. Nice finish on the contour there. It looks good. All right, we'll give this guy a test fit. It's going to sit right here. Looks like our hole pattern is lining up good. Our bolts are not going to work because now we've taken it down 1/4 inch. But what I can do, it looks like you're going to have a little bit of movement there, which is what they wanted. I don't think those are going to go, yeah. Nope, they're not. We'd have to put some washers on there to space it out a little bit, the head of the bolts, but we've got a little bit of movement, and that's just in the holes, the drilled holes over the bolts. So if we look at the back side there, I can see a gap. We have a gap in there. I think that's going to work fine. I don't feel that we need to go through there with an additional contour pass with our, compensation and take any more out of there, because it's already clearing, and that little bit of movement is not going to interfere with touching these 3 lobes right there. So I think we nailed it. That makes me feel so much better. I was getting really nervous about messing these parts up. This last thing I want to do is mess this stuff up and then have to buy them and put them behind schedule. I think that's going to work, guys. We'll go ahead and put the second one in there and get it finished. Our second bracket there. All right, it's ready to cut. We are ready to go. Looks like bracket number 2 finished. That looks great. All right, we'll give this a test fit. I got a little Noga tool here that we'll use just to deburr a couple of these edges. Just as easy as that. This don't feel bad at all. That's chamfered. Yeah, it feels good. All right, so this is the one. This is the second one that we cut. We just finished cutting that one there. I want to make sure that it's going to fit right, and I went ahead and got some washers to space out this bolt. They'll have to take. They can use these bolts, but they'll have to cut like a 1/4 inch off of them. That's a good sign. The bolts are lining up just like the first one there. It should. Got the same clearance around all three of those lobes. So they shouldn't have any problem with that lining up. I mean, it's just bolted in place and it's there. That is it. That job is done. I was nervous about it, but we got her done. Worked out great. Well, I got to say, I'm real happy with this project. I'm I'm proud of myself for being able to work myself through this project using my CAD and CAM and my CNC mill to get this done without actually having to email or call or somebody and say, hey, I've got an issue. Can you help me with this? Can you help me figure this out? It was a fairly simple job, but I managed to get it done, and I really enjoyed it. I love my tool room mill. That Milltronics is such a cool machine, and every time I get to use it for jobs like this, it puts a smile on my face and it makes me happy. And I was happy to be able to share it with you too. On the other hand, whenever I was going through this originally, I was thinking about how I would do it in the manual mill. Some of you guys might be interested in that too, and I'm sure a lot of you guys probably would have rather seen that. But I wanted to use my mill, I wanted to use my fusion to get this done, because it just makes it simple if you know what to do. And luckily I kind of knew what to do this time. But if I went to the other mill, I'd probably hold in the vise exactly the way I did in the mill. And what I would set up is my criterion boring head with a bar sticking out, and I would set that boring head to the exact diameter of this piece right here. Once I had that boring head set, then we could go in there and basically just fly cut it and bring, that arc of that fly cutter would come in to our zero, our stop position there against that wall. And you move back, bring the knee up, and you just keep making some passes through there with that boring head until you get down to the depth that you want. So that's how I would have approached it in the manual mill, but I just really love using my Milltronics. So this was a good little project for that machine. So anyway, this guy's finished up. I'm sure they're going to be excited to hear that this is done. They said that this is one of the last things that they're trying to get wrapped up on this build so that they can get it out of the shop, and I know how that means. I know what that means to try to get projects out of the shop and out of the way. So anyway, I hope you guys enjoyed. I enjoyed sharing this little journey with you, showing you how I use my granite plate and my height gauge to help get some measurements on, a part that's sometimes it's a little tricky to get measurements on there, but if you got the right tools, they really help you get the job done easy. So I was glad we got to show and use them. So anyway, I hope you guys enjoyed the video, and we'll see you on the next project, all right?